Are we alone in the universe? It is one of the oldest questions humans have ever asked. Long before radio telescopes, space probes, and exoplanet catalogs, people looked up at the night sky and wondered whether those distant stars were only lights in the darkness or suns of their own, surrounded by other worlds. Today we know that planets are common. We have confirmed thousands of worlds beyond our solar system. Some are gas giants larger than Jupiter. Some are scorched, rocky planets orbiting close to their stars. Others lie in regions where, under the right conditions, liquid water might exist. The galaxy is not empty. And yet when we listen for other civilizations, we hear silence. No confirmed alien signal. No verified extraterrestrial artifact. No undeniable evidence that another technological species has ever contacted Earth. That silence has a name, the Fermi Paradox.
Hi, I'm Liam, and you're watching Cosmic Nomad. Tonight we are talking about one of the biggest mysteries in science. If intelligent life should be possible elsewhere, why have we not found it? People report UFO sightings. Some claim encounters. Some even claim abductions. Science fiction has built entire universes around alien civilizations. But scientifically, we still do not have a single confirmed piece of evidence that an extraterrestrial civilization exists. And that is what makes the question so powerful. The universe looks like it should be full of possibilities. So why does it seem so quiet?
Enrico Fermi was one of the great physicists of the 20th century. He helped shape quantum mechanics, nuclear physics, and particle physics. He won the Nobel Prize. His work influenced the development of the first nuclear reactor. But his name is also attached to a question. According to the famous story, during a conversation about extraterrestrial civilizations, Fermi listened to arguments that intelligent life might be common in the galaxy. Then he asked something simple. Where is everybody? The power of the question comes from the scale of the Milky Way. Our galaxy is more than 13 billion years old. It contains hundreds of billions of stars. Many of those stars are older than the sun. If planets are common, then some civilizations could have appeared millions or even billions of years before humans. And if even a few of them became technological, why do we not see signs of them? No city lights on distant worlds, no obvious megastructures, no confirmed radio beacons, no alien probes in our solar system. The galaxy is enormous, but it is also old enough that in principle, a long-lived technological civilization could have had time to spread far beyond its home planet.
That is what makes the paradox uncomfortable. It is not just space is big, so aliens are far away. Space is big, yes, but time is also huge. A civilization only 1 million years older than us would be ancient by human standards, but young by galactic standards. And if it had the ability to send probes, build self-replicating machines, or slowly colonize star systems, it might not need faster-than-light travel. Even slow expansion could eventually cover large parts of the galaxy. So Fermi's question hits hard. If intelligent life is common, why is there no obvious trace?
The question of alien life is often mixed with UFOs, now more commonly called UAPs, unidentified anomalous phenomena. There are many reports of strange lights, objects, radar returns, impersonal encounters. Some cases remain unexplained because the available data is limited civilization would be almost impossible for us to understand. It would operate across galactic scales, using energy and engineering far beyond anything humans can do.
The Kardashev scale is useful because it changes the question. Instead of asking, do aliens exist? It asks, if they exist, how advanced might they be? A civilization only a few thousand years ahead of us might still look familiar, but one a million years older, that could be something completely different. Maybe it would build star-scale technology. Maybe it would become invisible because it uses energy extremely efficiently. Maybe it would not care about radio signals at all. And maybe we would not even recognize its technology as technology. To ants, a highway does not look like engineering. It just looks like a strange surface where giants die.
The simplest solution to the Fermi Paradox is also the loneliest. Maybe there is no one else. Maybe Earth is not just rare, but extraordinarily rare. Life may require a long chain of unlikely events. The right kind of planet, the right chemistry, stable conditions, liquid water, a protective atmosphere, plate tectonics, a large moon, a magnetic field, evolutionary luck, and enough time. Even if microbial life is common, intelligent technological life may be extremely rare. And if that is true, then the silence of the galaxy is not mysterious. It is expected. There is no one calling because there is no one there.
This is the most unsettling possibility, not because it is dramatic, but because it is so quiet. No empire hiding, no secret galactic federation, no signal we missed. Just us, a small civilization on a small planet, around an ordinary star, in a galaxy that may be mostly silent. But we should be cautious. The discovery of thousands of exoplanets has shown that planets are common. So the question is not whether there are worlds. The question is how often worlds become alive and how often life becomes technological. That is still unknown.
Another possibility is that life exists elsewhere, but most of it is simple. Microbes may be common, intelligence may not be. On Earth, life appeared early in the planet's history, but complex life took billions of years to evolve. Technological civilization appeared only very recently. For most of Earth's history, there were no cities, no radios, no telescopes, no spacecraft, just microbes, oceans, chemistry, and slow evolution. This suggests that the jump from life to intelligence may be difficult. Or maybe the jump from intelligence to technology is rare. If many planets contain life, but almost none produce civilizations, the galaxy could be biologically rich and technologically silent.
This is actually a very reasonable middle ground. The universe might not be dead. It might be full of life, just not life that builds radio telescopes. There could be oceans under ice, microbes under rocks, simple ecosystems on distant planets, but no one sending signals, no one building starships, no one asking whether we exist. In that version of the universe, Earth is not special because it has life. It is special because life here eventually learned how to look up.
The Great Filter is one of the darkest ideas connected to the Fermi Paradox. It suggests that somewhere between dead matter and galaxy-spanning civilization, there is a barrier that most life does not pass. The filter could be behind us. Maybe the origin of life is extremely rare. Maybe the evolution of complex cells was the hard step. Maybe intelligence almost never appears. If so, humanity may have already passed the hardest barrier. That would be good news, but the filter could also be ahead of us. Maybe technological civilizations usually destroy themselves before reaching the stars. Nuclear war, climate collapse, runaway artificial intelligence, engineered pandemics, resource exhaustion, or some danger we have not yet imagined. If the Great Filter lies in the future, the silence of the galaxy becomes a warning.
This is the part of the Fermi Paradox that feels less like astronomy and more like a mirror. Maybe the reason we do not see old civilizations is that civilizations do not last. Maybe technology is powerful enough to reach the stars, but also powerful enough to destroy the species that creates it. And if that is true, the most important question is not, where are the aliens? It is, can we survive ourselves? That is why the Great Filter is so disturbing. It turns the silence of space into a test.
Maybe intelligent civilizations exist. Maybe they know we are here. but they choose not to contact us. And this is often called the zoo hypothesis. The idea is that Earth may be observed but not disturbed, like an animal reserve, a protected experiment, or a developing civilization left alone until it reaches some threshold. There are many variations. Maybe advanced civilizations avoid interfering with younger species. Maybe we are too primitive to be interesting. Maybe contact is considered dangerous. Or maybe communication only happens when a civilization becomes mature enough to understand the rules of the wider galaxy. The problem is that the zoo hypothesis is difficult to test. It explains the silence, but it does not make clear predictions.
It is a fascinating idea, but also a slippery one. Because if aliens are hiding perfectly, then any lack of evidence can be explained by saying, that is exactly what they want. And that is dangerous scientifically. A good hypothesis should give us something we can test. Still, as a story idea, the zoo hypothesis is powerful. Imagine a galaxy full of civilizations quietly watching Earth, waiting for us to grow up, or deciding that we are not ready. Which honestly, after 5 minutes on the internet, is not the craziest judgment.
Another possible solution is much more frightening. Maybe the galaxy is quiet because everyone is hiding. This idea is often called the dark forest hypothesis. In a dark forest, every civilization is like a hunter moving silently between the trees. No one knows who is friendly, no one knows who is dangerous. Revealing your location could be fatal. A civilization that broadcasts loudly may attract attention. And if advanced civilizations are uncertain about the intentions of others, the safest strategy might be silence. Listen, hide. Do not announce yourself. This turns our own transmissions into a troubling question. Have we been too loud?
The dark forest idea is terrifying because it makes silence look rational. If you do not know what is out there, maybe shouting into the galaxy is not wise. On the other hand, Earth has already been leaking radio signals for more than a century, though most of them become weak and hard to detect over interstellar distances, and intentional messages have been rare. Still, the question remains, should humanity actively send messages to other stars? Or should we listen first, understand more, and be careful? There is no simple answer, because silence might protect us, but silence also keeps us alone.
Another idea is that alien civilizations may have visited Earth or the solar system in the distant past. Human civilization is very young. Written history is only a few thousand years old. Agriculture is only about 12,000 years old. Modern science is a recent development. Radio technology is barely more than a century old. If an extraterrestrial probe passed through the solar system 1 million years ago, we might have missed it completely. If something visited Earth before humans could record it, almost no trace would remain. But this idea has a problem. There is no confirmed evidence. Ancient myths, monuments, and unexplained artifacts are often used in popular culture as alien evidence. But scientific investigation has not shown that ancient civilizations required extraterrestrial help. Humans were capable, creative, and intelligent. We do not need aliens to explain human achievement.
I think this is worth saying clearly. Ancient people were not stupid. They built monuments, mapped the sky, developed mathematics, created art, and organized societies. When we say aliens must have helped them, we often underestimate human intelligence. Could an alien probe have passed through the solar system long ago? Maybe. Can we prove that? No. So it remains speculation. Interesting speculation, but not evidence.
Maybe the galaxy contains civilizations, but we live in a quiet neighborhood. The Milky Way is huge. Civilizations might cluster in regions richer in resources, older stars, or safer galactic environments. They might avoid spiral arms, supernova-heavy regions, or areas with unstable planetary systems. Our solar system may simply be far from the main centers of activity, or civilizations may expand slowly, selectively, and unevenly. The galaxy could be partially colonized without every star system being visited. In that case, Earth might not be special. It might just be remote.
This is the cosmic countryside version of the paradox. Maybe the galactic cities are out there. Maybe the highways are out there. Maybe the signals are out there. But we are in a quiet village, far from the action. And because we have only been listening for a very short time, We have not noticed the larger structure yet. It is not the most dramatic solution, but it is possible. Sometimes silence does not mean emptiness. Sometimes it just means distance.
Another possibility is that our technology is simply not advanced enough to recognize alien communication. We search for things we understand: radio signals, laser pulses, atmospheric pollutants, waste heat, megastructures, unusual transits, or other techno-signatures. But an advanced civilization may use methods beyond our current physics or engineering, or it may communicate in ways that are not meant to be detected by outsiders. It may use extremely narrow beams, it may transmit rarely, it may compress information so efficiently that it looks like noise. It may have moved beyond planetary surfaces, radio leakage, or anything we currently associate with technology. We might be surrounded by signals and not know how to interpret them.
This is a humbling thought. Imagine giving a smartphone to a medieval village. They might see light, glass, metal, strange symbols. But without the right context, they would not understand the networks, satellites, processors, or software behind it. Now imagine the gap between us and a civilization a million years older. Maybe their technology is not invisible, maybe it is just unreadable to us. Like a message written in a language we do not even recognize as language.
A civilization does not necessarily become louder as it becomes more advanced. It might become quieter. Early technology leaks energy wastefully. Strong broadcasts, heat, industrial signatures, and electromagnetic noise may be signs of a young civilization. But a mature civilization might become efficient. It may reduce waste heat, use tight communication beams, move into virtual environments, build habitats that are hard to detect, or choose low-energy, long-term stability over expansion. If so, the most advanced civilizations might be the hardest to find. Not because they are hiding from fear, but because advanced technology may become subtle.
This flips the usual assumption. We imagine advanced aliens building giant glowing structures around stars. And maybe some would. But maybe the truly advanced move in the opposite direction. Less waste, less noise, less visibility. A civilization that has survived for millions of years might be careful, efficient, and quiet. Maybe we are looking for fireworks. But the old civilizations learned long ago not to waste sparks.
Some solutions to the Fermi Paradox move far beyond conventional astronomy. Maybe the universe is a simulation. Maybe our reality is designed to appear empty. Maybe contact is being hidden by powerful institutions. Maybe super-intelligent beings are already among us, but so far beyond human perception that we cannot recognize them. These ideas appear often in science fiction and popular culture. But scientifically, they are difficult to evaluate. A claim that explains everything but predicts nothing is not very useful as science. The stronger the claim, the stronger the evidence must be. And at the moment, ideas like hidden alien contact, secret galactic control, or simulation-based silence remain speculation, not established knowledge.
This is where we have to separate imagination from evidence. Imagination is valuable. It helps us ask new questions. But evidence decides what we can actually claim. Could reality be stranger than we think? Absolutely. But possible is not the same as proven. So when we talk about aliens, the honest position is not blind belief and not closed-minded dismissal. It is curiosity with standards.
There's another possibility. Maybe we are not late. Maybe we are early. The universe is still forming stars. Many small, long-lived red dwarfs will shine for trillions of years, far longer than the sun. If life can arise around such stars, then most life in the universe may appear in the far future. Humanity may not be arriving after the party. We may be among the first guests. In this view, the silence of the universe is not a tomb. It is an empty room waiting to be filled.
I find this idea strangely hopeful. Maybe the galaxy is not silent because everyone died. Maybe it is silent because the story has barely started. We tend to imagine ourselves as latecomers in an ancient universe. And in one sense, we are. But in another sense, the universe may still be young in terms of life. Maybe intelligence is rare now, but will become more common later. Maybe we are not the final answer to the Fermi Paradox. Maybe we are one of the first attempts.
The Fermi Paradox has no confirmed solution. Maybe we are alone. Maybe life is common, but intelligence is rare. Maybe civilizations destroy themselves. Maybe they are hiding. Maybe they are too far away. Maybe their signals are beyond our understanding. Maybe the galaxy is full of life, but not the kind that builds transmitters. Or maybe the first confirmed signal will arrive tomorrow. That is what makes the question so powerful. It sits at the intersection of astronomy, biology, technology, philosophy, and survival. To ask where is everybody is also to ask, how rare are we? How fragile are we? How long can civilizations last? And what kind of future are we building?
Maybe one day we will detect a signal, a narrow beam from another star, a strange chemical signature in an exoplanet atmosphere, a megastructure blocking starlight in a way nature cannot explain. Or maybe we will search for centuries and find nothing. Both outcomes would change us. If we find another civilization, humanity will no longer be alone. If we find no one, then Earth becomes even more precious. Because consciousness, technology, music, language, memory, and curiosity may be rarer than we ever imagined. So the silence of the universe is not empty. It is a question. And for now, we are the ones asking it. This was Cosmic Nomad. I'm Liam. If this journey into the Fermi Paradox made you think, stay with us. Write in the comments. Which explanation feels most likely to you? Are we alone? Are they hiding? Are we too primitive to hear them? Or is the galaxy waiting for us to become ready? And I'll see you on the next journey. Until then, see you among the stars.